notation. That notation always means find the angle. So if this is the question, the answer is going to always be something degrees or something radians, depending on whether you're answering in degrees or radians. All right, so here we go. What does that first one say? Where's Maxwell? Huh? Thank you. Yeah.
I think he's still sick.
Yeah, he is. And tomorrow? Okay. All right. So this says, find the angle whose sine is √3/2. Now we know that there are millions of angles that have that sign. When the number right here is positive, find the angle whose sine is a positive. And whether it's a cosine or a tangent, doesn't matter. If this number is positive, you're going to draw your picture only in quadrant 1. You're only going to get one answer to all of these problems. If this number is positive, you're going to draw in quadrant 1. If it's negative, there are some rules that you'll want to write down and learn. But as long as it's positive, we're going to draw a picture in quadrant 1. And that means our angle will be between 0 and 90. Whatever angle we choose, it's going to be between 0 and 90 because it's in quadrant 1. Now, if the sine is √3/2, does that picture make sense to you? Which means this side of the triangle will be 1, and this angle is 60. So the answer to the question is 60 degrees. Oh shoot. Well, I'm going to have to change 60 into radians, but I can do that. 60 is pi/3. It's a third of 180, so it's going to be pi/3. Well, that's pretty easy. Let's look at the next one. This one says, find the angle whose sine is -1/2. Now, listen to me say that so that you're clear on exactly what you're doing. Find the angle whose sine is -1/2. Now, clearly that angle is not going to be in quadrant 1, right? Because we're not negative in quadrant 1. If it is a sine and it's negative, it goes into quadrant 4. Some smart people a long time ago made up the rules, and that's the rule. They could have put it in quadrant 3. They have their reasons. They put it in 4. So anytime you're doing a sine, or I'll give you a hint, or a tangent, if that number is negative, it's going to go in quadrant 4. So you're going to draw your picture in quadrant 4. And the sine opposite over hypotenuse, does that make sense? -1, 2, does that make sense? Yeah. And the angle, or excuse me, and that side would be √3, which means this angle is how big? 30? Would you agree with that? In degrees anyway, 30? Now, here's the deal. You can't say 30 because where's 30 degrees? Isn't 30 degrees in quadrant 1? So if I can't, it's not really 30, I went this way. What do I do when I go this way with my angles? -30. The answer to the question is -30 degrees. -pi/6 radians. Very good, thank you. -pi/6. If you're going down, which is what you're going to do every time you have a sine or tangent and your number's negative, you're going to be going down, and your answer is going to be negative. Negative 60, negative 45, whatever. Okay? Find the angle whose tangent is 1. Find the angle whose tangent is 1. Well, that's a positive, so we're going to draw it in quadrant 1. And if the tangent is 1, doesn't my picture look like that? Opposite over adjacent. So this would be root 2, and how big is that angle? In degrees, it's 45. In radians, it would be pi over 4. Perfect. That's it. That's all there is to it. Uh-oh. Find the angle whose cosine is 0. Now, be careful. Cosine is adjacent over hypotenuse. Could you possibly draw a picture? You think that is 0 over 1. Could you possibly draw a picture that looks like that? No. So if the triangle is not possible, what am I going to do? Draw the circle. And I'm going to look around the circle until I find the first place. I'm going to go in order. The first 0, 90, 180, 270. The first place where x is 0 and r is 1. Now, r is 1 the whole way. We made the radius 1, right? So where is it? Where's the first place? Is x 0 here? Nope. Is x 0 here? Yep, that's your answer. What angle is that? 90, which is pi over 2. Now, these problems I was able to do by hand because all of the angles involved were special. Okay, so the next section says, use calc and round it to 10,000 in decimal degrees. So make sure your calculator's in degrees. And just type it in. So second tangent, negative 1.43. 10,000. What did you get when you typed that in on your calculator? Go ahead and say it. Calculators don't lie. Negative 55.0349 degrees. Easy. Second sine 0.761. 49.5524. Everybody keeping up? Uh-oh. Uh-oh. Why am I saying uh-oh? I do not have that button. So I've got to do something to type this in because I can't just do what I did with these because I don't have that button. So this is where it is extremely important that you remember what it is you are doing. You are finding the angle whose secant is 1.98. If you were going to draw a picture of that, what is secant in terms of the sides of the triangle? Secant is hypotenuse over adjacent. You thought of that as a fraction. Now, tell me about this angle. What do you know about the cosine of that angle? So the cosine of the angle is 1 over 1.98. So I'm going to type on my calculator second cosine 1 divided by 1.98. Because the angle whose secant is 1.98 is the same as the angle whose cosine is 1 over 1.98. Some of you are going to get that confused. You must, absolutely must remember you're finding an angle. We don't take the reciprocal of angles. You've never done 1 over 60 degrees. Never will. What we take the reciprocal of is the function. So we take the reciprocal of the secant and make it a cosine. That's what I type into my calculator. And that's what I get. Okay? And we'll practice some more of those for sure. But first, we're going to find some, put the calculator down for a second. We're going to do some problems by hand, and then we're going to do the same problems with our calculator and make sure we get the same answer. Because if we don't, we're in trouble. By the way, I told you that sine and a tangent, if the numbers are negative, not -1 necessarily, but if the numbers are negative, these are going to go into quadrant 4. If it happens to be a cosine, we didn't have any in our notes, but if you are doing a cosine of a negative, that one would be drawn in quadrant 2. Do not shoot the messenger. I did not make up the rules. That's just the way it is. So if you are doing a problem by hand, and you're finding an angle, and the sine or tangent are negative, you're going to put it in quadrant 4. If the cosine is negative, it's going to go in quadrant 2. There's so much to remember. Yep, there is. It's just life in the fast lane. Here we go. Find the exact value. That means no calculator. So, in all math, we do parentheses first, right, PEMDAS? So let's forget this, and let's draw a picture of this. This says there's an angle out there whose tangent, here's the angle, the tangent is 1/10. Now I went ahead and made it a fraction so that I had an opposite and a hypotenuse, or opposite and adjacent. You could have made that, done 0.1 over 1. You could do that if that's easier for you. Now, what's the third side of the triangle? What would it be? If I use 1 and 10, I think it's a little easier than with decimals. What would that third side be? Square root of 101? Pythagorean theorem? Now that's a picture of the problem. What do I want to know? I want to know the sine. Well, what is the sine of that angle? Opposite over hypotenuse. And you don't need to rationalize that. You can leave it alone. That wasn't so hard. Let's try the next one. I'm going to find the secant of the angle whose sine is 2/3. So forget that. Let's just draw this. What does that look like? Well, opposite is 2. Hypotenuse is 3. Did you do your Pythagorean theorem and tell me what the third side is? And please do it right. Square root of 5. Everybody okay with the square root of 5? A squared plus B squared is C squared. If you said root 13, you're not putting your hypotenuse in the right spot. Now, what do I want to know about that? I want to know the secant. What's the secant going to be? 3 over root 5? Are you all right with that? All right. Tangent, cosecant. Anytime this number is positive, it's in quadrant 1. You're always going to be in quadrant 1 if that number is positive. If you're finding an angle, it's going to be in quadrant 1 if you're given this positive. All right, tell me about this triangle now. Where do I put the 3? Where do I put the 2?
It's hypotenuse.
3 is hypotenuse. Opposite is 2. And this side is, once again, root 5. Wait a second, does it make sense that the angle whose sine is 2/3 is the same as the angle whose cosecant is 3/2? Yeah, that makes perfectly good sense. These two triangles are the same. What's the tangent? 2 over root 5? I want opposite over adjacent. We'll leave all these up here because we're going to check them on our calculator. Okay, that number's negative. What did I tell you about where you draw your picture if it's a sign problem and it's negative? 4. Find that missing side. Let me know when you got it. Square root of 24, which is 2 radical 6. Everybody get 24. If you got 26, you're messing up again. This is the hypotenuse, so it has to equal 5 squared. All right, what do I want to know? I want to know the cosine. The answer to the problem is 2 root 6 over 5. Perfect. So these were the by hand exact answers to the problem. Is everybody still with me? Because now we're going to type them in on our calculator. Problem 1. That is so easy to type in. Sine, second tangent, 0.1. Now I got 0.0995. Did you? Now I'm going to check that. 1 divided by the square root of 101. Perfect. Here's where we gotta wake up from lunch now. We gotta talk about how we're gonna type this in on our calculator. Now, can we type that in? Yeah. And that's going to be an angle. If you type that in, it's going to be an angle. You want to take the secant of an angle. How do we find the secant of an angle? 1 over the cosine. So this is going to be typed in as 1 over cosine second sine 2/3. This is an angle. You could type that in and get whatever, 45 degrees, whatever it is. And then you need the secant of that, so it's going to be 1 over the cosine of that angle. So 1 divided by cosine, second sine, 2 divided by 3. I got 1.3416. Did you get that? So let's check it. 3 divided by the square root of 5, exactly the same number. So again, in this problem, we were finding a secant. To find a secant on our calculator, we have to do 1 divided by cosine. Okay. This is an angle. It's an angle whose cosecant is 3/2. That is the same as the angle whose sine is 2/3. Does that make sense to you? Here's a picture of it. If the cosecant is 3/2, isn't the sine 2/3? So that's what we type in. We type the tangent of that. Sometimes we get confused because we want to do 1 over. You have to pay attention to what you're doing. .8944. Do you see the difference between the secant here and the cosecant here? If you are finding a secant or a cosecant, you're going to do 1 divided by. But if you're dealing with an angle, you have to rewrite the angle in terms of the buttons that you have. So you cannot second cosecant, so you got to change that to a sine so that you can second sine. Okay, that's the only way to do it. If it's an angle, you got to physically change it to the new function. And finally, what's the last one right here? I got all those buttons, so here we go. Cosine second sine -1 divided by 5. 0.9798. 2 square root 6 divided by 5. Yep, perfect. You okay with that? Okay, we're gonna do one more problem here, and I'm gonna skip 5, we're not gonna do 5. And number 6, we're only gonna do part A in number 6. Alright, so let's see if we can figure out number A, because it looks so complicated. But I don't think it is. Alright, so let me draw the picture. And then we're supposed to show that theta is this. Doesn't that look crazy hard? But it's not. Here's what I want you to do. Theta is this angle right here. This is a right triangle. Theta is this angle right here. That is the angle if a guy is looking at this picture. This is a picture on the wall. The bottom of the picture and the top of the picture, that's the angle his eye's making. So the top and the bottom of the picture. Now, let me call this angle right here, this pink angle, let me give him another name. How about A? Would you agree that the tangent of angle A is 2 over x? Now look at that little triangle down here on the bottom. Would you agree with that?
Yeah.
So A is the angle whose tangent is 2 over x. If the tangent of A is 2 over x, then A is the angle whose tangent is 2 over x. Now let me call this angle B, the whole thing. What can you tell me about the tangent of B? Now B is the whole angle there. What is the tangent of B? 14 over x. So B is the angle whose tangent is 14 over x. Now, theta is the angle that's really in the problem. How can I get theta? Is theta gonna be B minus A? So theta is B minus A. No question about that. Theta is the purple angle minus the pink angle. But we already said B was the angle whose tangent was 14 over x. And A was the angle whose tangent was 2 over x. So that, you just proved it. It's easy. Now you might be thinking, well, Mrs. Ford, why didn't we just do theta? Why didn't we just do tan theta? Why did we mess around with these A's and these B's? Can somebody tell me why I didn't just do tan theta? Yeah. It's not a right triangle. Now, in chapter 5, we're going to be able to handle it. But right now, the only trigonometry we know is SOHCAHTOA. And SOHCAHTOA is right triangles. So I had to look at the 2 right triangles, the little skinny one and the big one, and then subtract to get the angle that I need. Is that okay with everybody? All right, we're gonna do a couple more problems and we'll look at some homework if you wish, but we're gonna do a couple of these word problems. The only section left is 4A. So we'll be having a test sometime for too much longer. Lord, I hope it doesn't fall on next Monday. That would be terrible, wouldn't it? Well, next Monday doesn't bother me one bit, but I think the Super Bowl is Sunday. And I think some people like watch that.
We don't
So-
have class on Monday, so it's okay. We don't have class on Monday.
Oh, we
Why
don't?
don't we have class? Well, we
Oh,
don't have
because
this class.
of the day of the cycle?
Yep.
Then it won't be Monday, guaranteed. No test on Monday for sure. All right. Thank you for pointing that out. How do you know that?
I always look like 3 weeks ahead.
All right. Draw a picture, write an equation, and solve it round to the nearest hundred. We did a few. The first number 1 here, these are kind of easy. And then some of these other ones get a little bit more complicated. But let's see how we do with number 1 because we've already talked about these. We have a bird in the top of a tree. The bird is 18 feet above the ground. Find the angle of elevation. When we did these before, did we talk about how your angle of elevation is always going to be here? And so is your angle of depression because these are congruent, right? Now where do I put the 100? I gotta put 100 somewhere. Where does that 100 go? The 100's gonna go at the bottom. How do we know? Base of the tree. Write an equation. Sine, cosine, tangent. Make your life easy. Use sine, cosine, or tangent. Which one? Tangent. So always tangent angle. So tan x in this case equals 18 over 100. Who remembers how to type that in on my calculator? How do you get an angle on your calculator? There's only one way to do it. Second tangent. Yep, second tangent. Don't multiply, don't divide, don't do anything crazy. Just second tangent, 18 divided by 100, and your angle is 10.20 degrees. Anybody have a question about that? All right, let's try B and C, and I'll have some volunteers put these guys up on the board. We'll put B and C up here. Anybody who thinks you've got a plan? Come on up. Yeah, that's totally what I want you to do.
I didn't know if I heard you right.
You did hear me right. I'll get out of your way. Don't forget to get blood on Wednesday.
How do we sign up?
Any of the signs in the hallway, there's posters all over, you just scan it,
Oh,
and you sign up that way. If you signed up before, you have to re-sign up because that, for the snow you had, yeah. Of course, anytime you get blood. You gotta get, have to sign refusal, and you're not gonna do that once. Okay. Then go sign up and see what they say. 8 weeks. So, if you started by saying, well, you could continue to do it.
yeah, I just
Oh, I didn't know that. Okay.
Trying to make sure. Last time they refused me.
All right, who's doing the second one? Who's doing C? Jake's almost done with B. Who's got C? Get up there, Robbie Rack. We'll take you up and put you down.
Let me do it.
Never
Let me
mind.
make sure.
Meg, are you done with it? Nyla, you got it? Yeah, we need somebody to get up there and do C so we can talk about it. Remember, your angle always goes here, guys. On these elevation and depression problems, your angle is always going to go right there. Now, for problem number A, we use second something, right? Second tangent or something. Neither one of these guys is doing that. Why? Why did I use second tangent, but they're not? They're not finding an angle. We only do second when we're finding an angle. So they're doing regular arithmetic to solve their equation. And let's talk about them and see what you think. So, first of all, here's the worm on the ground. Here's the bird in the top of the tree. Does he have the 19, the 24, and the X in the right spot? Do you agree with Jake's placement of the 19, 24, and X? I think he's right. So he said, I'm going to use sine. Sine 24 equals 19 over X. He times by X divided by sine 24. He got 46.71 feet. Anybody else get that? Perfect. Perfect. All right, C. How tall is a flagpole? Okay, so does she have her 23, her X, and her 32 in the right spot? If I go outside and stand in the sun, here I am standing in the sun. Where's my shadow? On the ground. My shadow's on the ground. So the 23 needs to be down here on the ground, which means that our function will not be sine, it will be tangent. So tan 32 equals x over 23. So 23 tan 32. Now, does that make sense to you?
Yeah, I got it once I sat down.
I got 14.37 feet. Any question about that? Any of that? Good? All right, couple more. Number 2. Kirsten places her surveyor's telescope on the top of a tripod 5 feet above the ground. All right. So here's her tripod 5 feet above the ground. Here's her telescope. And she's looking up at the top of a tree. And she measures an 8-degree elevation to the top of a tree that is 120 feet away. Where does 120 go? So this is 120. Here's the tree. Where does the 8 go?
Like that.
Remember, it's measured with the horizontal. So isn't this the 8?
Yes.
And that dashed line I just drew in, isn't that dashed line 120?
Yeah,
Huh?
yeah.
So, can I find this X right here, this X right here, can I find that?
Yeah.
Using what function? Tangent again, so tan 8 equals X over 120. So I got 16.86 for this. But if I want the height of the whole tree, I'll have to add this 5 back on. So the answer to the whole tree is 21.86 feet. Are you guys okay with that? Okay, one more. A U.S. Coast Guard patrol boat leaves Port Cleveland so let's put Port Cleveland right here. And the boat travels on a course of 53 degrees. Now remember, if I'm doing navigation, these are my labels. So this is 53 right here. He averages 35 knots, and knots are nautical miles per hour, traveling for 2 hours. So how long is this? I'm gonna do a little bit longer. How long is that? If he went 2 hours at 35 miles an hour.
How far is it?
Uh-huh.
70.
70 nautical miles. Then he changes course. So now he's here. And he goes on a course of 143. So 143 would be down here. Does everybody agree with that? Remember, we're on a compass now. So straight down is 180, so 143 would be in there somewhere. And he goes 3 hours on that, so that's gonna be longer. How long is that one if he went 3 hours? 105. And now the boat's here, now he's here. What is, what is the boat's bearing and distance from Port Cleveland? So here is the distance, would you agree with that?
Yes.
I kind of guessed, but that's it, that's the distance, we'll call that X. The bearing is his direction, so that would be this green angle right here. From Port Cleveland, that's his bearing. All right. Put your thinking caps on. We gotta figure some stuff out.
Can we put in that little, in the green, or like, in that, what's it called? Angle? Cause you're trying to find that angle, right?
This one?
Yeah.
Yeah.
So could you put like 10 there and then do 70 over, or negative 10, and do 70 over,
Wait,
or
is it just
105
53
over?
plus 59?
No.
Well, okay, if that's 53, this part right here would be 37,
Yeah,
but I do not know this part.
I'm not like worried about the numbers, it's just like that angle, isn't it 105 over 70, or 10, negative tangent 105 over 70, or no?
Well, if I have a right triangle,
Oh, I didn't think about that.
yeah, gotta have a right triangle. Now, here's the good news, I think I do. Because if that angle's 53, then this one right here is 53. How do I know that? These are parallel lines, right? That's a transversal. These are alternate interior angles. So if that's 53, that's 53.
And that other one's
Now,
37.
I know that if that's 143, doesn't this piece of it have to be 37
Yeah, so it
to
is
make
like-
180? And 53 and 37 is indeed 90. So, Jake, I can't just assume it's 90. I have to figure it out, make sure it is, and it is. So, now, like you said, let me call this brown angle theta, the whole big brown angle made by purple and pink. That, this is my right triangle. Can I say tangent theta equals 105 over 70? This is my right triangle, it's kind of upside down. This is the hypotenuse. This would be opposite and adjacent. So can I say that? So second tangent, 105 over 70. Sometimes we have to think, guys. I got 56.31. Now, that's just the black, or the brown, so I gotta add the 53 to it to get the whole green angle. So adding 53 to that, my bearing is 109.31 degrees. So basically what you just did is figure out that if this guy goes up here and then down here and then he starts taking on water, you can send the rescue boat out and tell them that's the course they need to go on to get to him. Now, what's x? How am I gonna find the distance x? Pythagorean theorem. This is a right triangle, remember? That's the hypotenuse. So x squared equals 70 squared plus 105 squared. And don't forget to square root it. 126.19 miles. Back when we did this before, did we talk about nautical miles? No? Okay, well, we need to just touch base real quick. This isn't anything huge. But have you heard the word knots before? Like in this problem, knots? Knots is a speed. It's nautical miles per hour. It's not a distance, it's a speed. When have you heard that word used? In the movies, when what kind of things are moving? Boats, ships, airplanes, space shuttles, things like that, right? When I get in my car to drive to school, I don't measure my speed in knots. I measure my speed in miles per hour. They're called statute miles, 5,280 feet, statute mile. When things are traveling long distances, I want you to think about it. Here's the earth. That's the whole earth. Here's my house, and here's Cathedral. When I drive to Cathedral, isn't that pretty much a straight line? Because compared to the earth, that's a very small distance. But what about if I were, this is my house, and I wanted to go to England? That would not be a straight line. That would be an arc, right? To take into account the curvature of the earth, when things travel long distances, like airplanes and stuff like that, we use nautical miles, which are like 6,080 or something feet per feet. They're longer because we're measuring over the curvature of the earth. Knots are just like miles per hour, treat them just like miles per hour, only they're nautical miles, not regular statute miles.